Here we go. Woke up this morning around like 8 o'clock. Wasted some time in bed. Realized I was wasting time and then actually got up and did something with my life. I had to edit pictures for like, I went to Starbucks at 9:30. I didn't get there really till 10. I got back here at almost 1. So I spent about 2.5 hours editing for the longest time. But on the docket today is edit pics. The gym I didn't go to yet. I'm going to do the string problem now. And then I'm going to finalize the finance app design today. So I was working on an app design yesterday. We're going to have 3 or 4 components. Well, actually 3 components, all going to my email. What that means is we'll have a transaction processing service, and there will be an email sending service linked together by a RabbitMQ message queue, basically. So essentially what's going to happen is we're going to process data on a cron job, and then based off that, we'll send a message to the queue. The sender service will listen for that message and then send off the email in a formatted fashion. So today I'm going to finalize the design. I'm going to design the email. Right now it'll just be text, I think, nothing too complicated. You can add more data to it later as we maybe build out the features, but it's supposed to be done in a week. So I've got until next Sunday to complete it. Then I'll pick up my next project. As I'm finishing up this one, I'll decide on a new project to build for the next week before Jasmine gets back. Yeah. Anyway, we're here to talk about string problems, not the app. So, longest common prefix. So one thing I realized about these string problems is that they usually use a loop, for loop or while loop, and you're checking conditions most of the time. So let's see what this one's all about. Write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, return an empty string. So for example, flower, flow, and flight, the longest common prefix is FL. FLO is on 2 of them. Since there's only FL here, okay. So let's start with this example. Well, let's start with this one too. So let's take a look at it. There's DOG, there's race car, and then car. Since there is no common prefix amongst the input strings, okay, cool. So we're looking at, it's a common prefix. So a prefix suggests that it's not a common substring, but literally a prefix, right? And so some of the clarifying questions I might ask in the interview is, when you say prefix, do you literally mean like a prefix to a string, at the beginning of the string? They might say yes. So given an array of items, flower, flow, and flight, we need to find the longest common prefix. So F is a prefix as well, but a longer one is FL. And then FLO is valid until we get to flight. So let's take a look. So if we take the word flower, right? How do we start to look for a prefix? Well, we know that the prefix starts with the first letter, so F. So for a prefix, we just assume that the first letter is a valid prefix. We basically are going to loop through each letter. We're going to look at the prefix for each word in the array and look for that prefix as well. So for example, this is valid. So our answer starts out, blank, empty string. And we take the first letter of the first word, which is an F, and we check for that F in the rest of the words. So we first take, so our current prefix is F. So our answer will append like, we'll say like array at 0, and then we'll say like at 0. That's the start of our first prefix. Now, the order doesn't matter, because if we had flight, we'd still take the F and check it across the rest of them. So we want the longest common prefix. So F is valid because we're starting with it, and it continues to be valid because if we look at flow and we look at flight, F is there. Okay. Then we add the L. And we say, is FL valid? Well, FL's in flower, FL's in flow, FL's in flight. Cool. We then add the OW, the O. Flow is in flower, flow, FLO is in flow, FLOW. FLO is not in flight. So our answer still remains FL. Because it's a prefix, we can stop the check there, break out, and return FL. Okay, let's dig more into the actual like iteration logic. So I'm thinking that we initialize our current, I guess, like some kind of pointer, a tracker of our prefix. Trying to think across. Because our answer is empty until we find a proper. So we have to use a current tracker. So current will pull. So we're gonna loop through what each word. So for each, I'll say for word in array. Right. So we have a first word. Our current prefix. I'll say current pre is equal to our word at 0. And right, this is valid. Well, we'll say, current can be whatever. Current can be blank. Right, and our answer can be blank. Let me delete that, erase that. So we have answer, which is definitely blank. Our current is blank. Current, we can say plus equals. I might say just current. I would say current dot join word at 0. So give us the L, give us the F, and then we have to check. This is for each word, right? We're gonna look at each word. We're gonna look at the first letter of each word. So our current is currently pointing to F. Well, really, since the order doesn't really matter, because at any point we can make this invalid, right? And if, and even the quicker we do it, the better, right? But that's not, I think that we're pinching pennies at that point in terms of time complexity. So for word in the array, we're going to check if, we're really validating a window, right? Like this is more about windows a little bit. The window is 0 to 0, right? We're slicing the first bit and we're basically checking that, okay. So one approach I'm thinking of is why don't we just hold the first word, right? Or we can take the shortest word. So if we have flow, we know that it can't be longer than flow. Our prefix can't be longer than flow. It's either flow, the entire word, or so we can do it. We can run a quick algorithm to find the shortest. Let's say we have that, right? We just get the shortest word. So shortest word is equal to, we'll say flow, and our current is the first letter of the shortest word. And then for each word, I guess minus the shortest one, we're going to check for the letters of the shortest word in the other words. Right? Is that valid? That's okay. So we'll initialize our current to be the first letter, which is F. We could just sort it. Sort, or it's n length. Sort n log n. Is n faster than n log n? Yeah, I think an n length find is okay. Removing flow, yeah, not great. Okay, so we have our shortest word, we have our current answer, we have an answer, a final answer, and we have our current prefix. So current prefix starts with F for word in array. We're checking the same window though, like start to end. But is it really that complicated? Is it really that complicated? Our start. Okay, let's. I mean, we can try that. I haven't completed a single solution yet. And my timer. Ooh. I have 20 minutes, right? Okay. I have 20 minutes left. Okay. So I'm getting mumble jumbled. I'm getting all over the place. I'm going all over the place. So let's say we have an end and a start, right? And our current prefix is end to start, and they both initialize at 0. So if we slice the shortest word from 0, I guess from end to start, right? Or I guess from start to end. Okay. That's our current. So if we take the same slice from each word, so we just say like, okay, so we don't even have to initialize it, right? Because we have a pointer to start and end. So we can just say, let me just say what? Let me just say if this window is here, right? We'll say if word at start to end in that window equal shortest word start to end. Okay, if not, return answer. If we exit this loop, then we just if we exit this loop, we're gonna return a slice. We'll just say return. If we okay, here's the logic. Return shortest word from start to end as a string. Okay, here's the logic. So we run a quick algorithm to find the shortest length word in the list, because our prefix can't be longer than the shortest length word. Our prefix could be one letter, it could be all letters in a word that, so if, for example, if we had flow and flower, the longest prefix would be flow, right? It'd be the word entirely flow, but it's also a prefix of flower. So what we're saying here is, okay, we find the shortest word, which is flow. We don't sort anything. And then we say our final answer, we don't have an answer holder anymore. We initialize two variables, end and start, or start and end, which will control the window of characters of the shortest word. And then we loop through and we say, okay, so for each word in the array, if the prefix, if the slice, start to end slice of the current word is not equal to the same start and end slice of the shortest word, meaning if our current word is flower, right, we're checking to see if, this is our first iteration, so we're looking for 0 to 0. So if f is equal to shortest word 0 to 0, f, really I'm saying, sorry, if not f equal to f, which it is, but that's a bad example, right? So let's use our other one. So let's say we have dog, race car, car. Our shortest word here is dog or car, it doesn't matter. Since dog is the first one, I think we'll stick with dog. Start to end is 0 to 0. That means our current prefix is D. If not, current word, which would be dog, equal to the shortest word, which is dog, then we return an answer. Return what? Yeah, we need to answer to keep track of our current slice. So if at any point we do come out of this, we still need we basically need the shortest word at the current slice, which is basically what we want, right? Then we check again and say, okay, if D, right, not equal to R, which is true, return what? So for example, okay, so let's take a look. Let's say there's no answer. Technically, D is not the right answer, right? So how do we return the proper slice? Because if there is no answer, okay, maybe we need an answer variable to hold something. And then our answer gets updated to be, answer just gets a slice of the shortest word. So answer starts with a string. And if all of them pass, so let's see. So if we break, we just return answer. And answer is simply a slice of the shortest word from start to end. That's not valid, really. Oh, damn it. What am I doing? What am I doing? We'd say answer.join the slice. So my point here is that the algorithm should adjust our window of like the prefix. And then based on what the window is finally becoming, then we then just join, maybe answer with the shortest word at subsequent prefix. So I mean, that could be the way to do it too. You say answer dot join, right? But then that means that start to end damn it. I'm running into a quick little snafu. So basically we have start and end, but we need to return an empty string in case none of them match. Is that making sense? Like, answer is an empty string, and we want to return answer. I mean, let's step through it, right? So we got dog. We want start and end can still be 0, so we can still convert the D to the R. And once that fails, we know that the rest of them doesn't matter if they match, because fuck it. But If that fails, then we know that we've stopped our prefix search. We're basically going to be searching until we hit a failure point, basically, is kind of the point. And so basically we're saying, okay, we're going to loop through each word each time. Well, we'll break later. The return cuts us out. So if end, how do we return an empty string if it fails early? So ultimately we want to return answer. If we make it through the string, then our answer we already know is not going to be empty. Does that make sense? So if we get past this point, then we know this is okay. Right? Is that right? So we know that answer.join start to end is okay. Because we've already made it through the iteration once. So for example, in the case of dog, answer starts out empty. Once we move past, so let's walk through it, right? So we say, okay, current word is dog. So current word is dog. Our shortest word is also dog. That way, if not D equal to D, that's not true. So we pass that. If not D equal to R, return answer. Answer is still blank. Therefore, returning answer is fine here. So for example, in the case of flower, flow, and flight, is F equal to F? Yes. Is F equal to F? Yes. Is F equal to F? Yes. Move the start up 1. Is that right? Is that correct? Because we really want 0. We really want 0, 0, not 0, 1. Well, that means you start at -1, right? That's even valid? This whole window business is getting me a little bit messed up here, but let's keep walking through it. So now our window is so after we get through the first one, our window then becomes, so that means F is now a valid prefix. Once we get through the all time, is F equal to F? Yeah, that's all valid. But how do we actually check that though? We didn't, because start and end was -1 to 0, which is not a valid window. It's not a proper, so the solution's not going to work. Okay, let's start over. I think there's something solid here, but I'm not exactly sure. I'm not exactly sure yet. We're gonna continue searching until we hit condition, right? So if we do grab like the first letter, right? If we grab the first letter, let's say we grab the first letter of the first word. So our starting prefix can be F. So our answer starts out empty. And we say for a word in array, so what are we really comparing? We're comparing, the first letter of the first word. So we'll just say like array at 0 at 0. That's cur. Then we're saying if cur equal to word at 0, equal to word at 0, then we're good. If not, then this is good. This is good. We want this to work. Else, we probably want to exit. So return answer. I'll say return. And then if that's not the case, then we want to increment our prefix. So we're actually going to have an end variable, at least. The end will always restart anyway. So our end gets moved but only after we've looked at every single word. So I say word at end. Well, it's a slice. It is a slice. We're checking the entire slice. Well, actually, we don't have to do that because if we passed the previous ones, so if f passes all of them, then we just care about the end. Because then we can say f. Then we're checking the L. Is that making sense? So we know that if the f passed, cool. Our end is now what? It was 0. Answer was blank. Trying to answer. Answer gets what? I cannot. For some reason, I always have this issue where I'm thinking of a million different solutions at the same time. Like I can't focus on completing one solution. I think that's my issue. That's the problem I have. I can't focus on finding one solution and then completing it and then running tests against it. I'm always like, what about this? What about that? Okay. Let's walk through it in English. We're worried too much about code. Let's go back to the English explanation. I got some time here. 5 minutes, not even. So let's go through the English translation. We'll try to get it in English and then translate it to code. So if I'm running through this list, flower, flow, and flight, I want to take basically the first letter of any one of these words and check that it's also the first letter of the rest of the words. So if I grab the first letter of flower, which is F, I want to check if first letter is the same for all words, and then check if second letter is same for all words, right? That's what I want to do. We want to step through, and if F is the same, then it's a part of our prefix. So we know that if we're going to look at the first letter of each word, that means we just need one pointer, right? So we need the word and we need an index. So we just need a word. We need the word and the index. So as you loop through each word, you can say for, again, word in array. We need a pointer, PTR 0. So as long as it's all good, we're good. Right? So as long as we're stepping through it, we're fine. So our pointer is okay. Equals 0. Our answer is still, so if not, so we kind of need a prev, because we're comparing like against each other. So we kind of need a prev. So what we're really going to say is what? We can use a while loop too, right? We can probably use a while loop too. All right, let's just do it like this. Let's do it like, we can say I in range, we'll say length of array -1, right? And we'll basically say if not array at I at pointer equal to array at I plus 1 at pointer, then return our answer early. Else, if that runs, so basically we're having a doubly nested loop. So for each letter, we take a stab at making this possible. So we need a while. We need basically need a while. We need a while loop and a for loop. We need 2 iterations. So we need a while. While what? I don't know. So that's where the shortest word comes into play. Yeah, so that's where the shortest word comes into play too. I got you. Okay. So our shortest word is flow. So I guess we'll say while so while pointer is less than or equal to length of shortest word minus 1. I probably feel it's not right, but is that right? So 0, 1, 2, 3. So while length of word, then we'll say for shit. That's fine. I'm gonna keep going because I think I got it. I heard somebody walk by. Okay. So a pointer is less than that. We're gonna take our pointer. We'll initialize it out here. PTR equals 0. Our answer as well. Empty string. Then we'll say pointer. Right? We'll say for. What we're saying for each word still, or what? We're saying that. I really want to say less than, not equal to, less than. What am I saying here? So pointer is stepping through the shortest word, right? Because we can't have a prefix longer than the shortest word. Does that make sense? And so then we say for I in range length of array. Then for each word in the array, we then say we compare. Yeah, so for each word in the array, compare the pointer letter, the letter at pointer. So we're basically saying if not, return our answer early. If this all succeeds, then our answer should be updated with now the letter at that word. The letter at the pointer. So answer is a dot join, I guess. Enter dot join shortest word at PTR. And then PTR plus equals 1. The return answer. Is that valid? Is that gonna work? So we have our shortest word is flow. We then say while PTR is 0 less than 4. Then we say for the current word in the array. If not F, so we'll say flower, comparing it to the first word in flow, which is F. If not F, then otherwise we move on. Then we compare flower to flight. That's fine. Our I was 0, our I is 1, length is 3. Minus 1 is 2. So go from 0 to 1. Cool. So we compare the first letter of each one. Then we want answer to then become dot join shortest word at pointer, which is now we're joining empty string with an F. And we're going to increase pointer to be 1. Okay. Then we set, and pointer is still less than, so 1 is still less than 4. So we're going to go to loop again. We say for each word, if not array at I at pointer, which is L, not equal to L. Okay, that passes. L equal to flow compared to flight passes. We append answer, which is an L. all right? And we move pointer up to 2. Now we're looking at the third letter in the shortest word. We're comparing the O to the O. So flower compared to flow, cool. Then it says if not O equal to I, then we return our answer, which is FL. Okay, what about dog and racer? Let's look at that example too, make sure that works. Dog, racer, what? And car. So we have answer, our answer is blank, pointer pointing to 0. And, okay. Our shortest word here is dog, basically, or car, whatever one gets checked first. We take pointer at 0, we then say for pointer less than 3. So 0 is less than 3. We say for each word, compare the 0th letter. So if not D equal to R, return answer, which is blank. Okay. I think this works. Let's try it, code it up. Okay, so pointer equals to 0, answer, empty string. And we'll say the shortest word will this ever be 0? Well, we'll always have at least one word. So what if it's one word? The longest common prefix is then what? What if it's one word? Because this is, the length of strings can be between 1 and 200. A string itself can be empty. What about that test case? That's a whole, yeah, I need to get better at coming up with test cases. Because wow. String, and what does it say? For word in strings. We're gonna find the shortest word. Can I just do a min function? It compares two things, right? Yeah, we can just run a min function real quick. Let's run a min function. Min of strings. Shortest word, so while PTR for I in range, length of strings, that's 1. We say if not strings at I at PTR equal to what strings at I plus 1 at PTR, then return answer now. If that all succeeds, then we just give answer dot join the shortest word at PTR. PTR plus equals 1. And return answer out of that. Is that right? Does that make sense? Test it. Ooh, failed. We returned FL. can't always print it. You have to know how code works without having to run that. So we print out a high twice. This doesn't work. Our join doesn't work. Why not? Why doesn't our join work? Yeah, so it gets high twice. Our join isn't working, I guess. It's 0 and 1. Okay, let's print this out. Oh. The dot join returns a string, I didn't know that. What? Okay, I don't want to do plus equals though. What do you mean? Answer gets answer dot join. Ugh. Plus equals is not good. It's not very Pythonic though. String concatenation should not be used with point. I don't want to use the concatenation though. This solution even work? It does work. Beats 97%. Whoa. So this is success. So it's success, right? It's success, right? So congratulations, it worked. Checking email for some reason. What? Okay. I want to use that join. What can I use answer? It returns a string. So I'm saying I want to join with our previous answer. Am I crazy for that or not? I get L. I'm missing the F. Print. I mean, so we're gonna get this, right? This is valid. I'm not using the join correctly. Let me put answer as well. Why don't I plus it doesn't make sense either. Then why even use plus equals? Then why even use dot join? Python. What am I doing here? Oh, it's a separator. It's not really concatenation. It's okay. Hold on. So concatenation is a plus. But plus like creates a whole new string, I think. So dot join is better for that. But the plus is concatenation. You can bring two words together. You think because I'm using an array? Right? Is that valid? So what's answer after each join? Let me see. So answer is F, and then so before answer is blank, then it's F. And then it's F. And so F dot join L. What? I'm so confused by that. I cannot believe that doesn't work. Like, is that real? Yeah. So after it's F, so then it comes in F, and then F gets F dot join L. God, that is so weird. Okay, whatever. Whatever. This is the answer. It works. Submit. Done. It took me a little longer than 30 minutes, but I figured it out. So let's review quickly what we did right there. So starting over made sense. Trying different solutions made sense. It passes test cases for LeetCode, which is good. What went wrong earlier? Well, what went wrong earlier was I was trying to come up with like a cool with the slicing, and the slicing was overcomplicated. I then realized that we don't really care about comparing the slice. So we've already compared the F in each one. We either exit early or compare the second letter. We don't really care about the entire prefix. So it's good. I'm happy with that. It's good. Love it, love it, love it, love it, love it. Pick the solution. Wow. It beats 50% memory-wise. 14 megabytes. Damn, why? Anyway, the runtime complexity is what? Well, in the worst case, we have all the same letters. So this runs n, and this runs n. So this is an n squared solution. Because if we have an array of all flowers, we compare every F, every L, every O, W, E, and R across each and every word. Building up, again, a string that, so space complexity, worst case is O of n. Runtime complexity is n squared. No, is it n squared? It's n times m. Because it's the shortest, it's m being the length of the shortest word compared to n words. That's not right. I think it's Yeah, it's not fast. What does what do LeetCode have as a solution? To employ the idea, equates to strings s, finds each iteration I the longest common prefix. Empty string and okay. Fine. They have only in Java. It's O of S. So they have a for loop and a while loop. Okay. They don't have it in Python. That's nuts. They have it, what is that, a divide and conquer algorithm? Oh my god. A binary search? Oh my god. If I hadn't improved this, I wouldn't even know how to improve it. Java, simple Python solution. Let's see, what do they have? So if not, return empty. For I, letter, and group, zip up, unpack the strings, and zip them up. If length, a set of letter group greater than 1. Whoa, whoa, whoa. What? What? Oh, you can use reduce. That's kind of nuts. Reduce does what again? I forgot. It's a yeah. You can also use that as a for loop too, but the prefix people are like they're kind of slicing a little bit. Yeah, so I always want to find the source one too. $32 MS. What was my solution? That doesn't matter. So he's got, might be a bit slow. So we're enumerating, we're zipping the strings. So basically it's this zip of the strings does what? Since each string is an iterable, it'll zip to the shortest word, and we enumerate that. So in the case of flower, flow, and flight, it'll have flow. And then it says if length of the set of a letter group of the unique items is greater than 1, then return strings at 0 to I. I gotta look more into that. That's crazy. Definitely not something you would. It's not obvious what's happening here. I mean, you know what zip does, you know what enumerate does, but you have to kind of think a bit about it. So I wouldn't go for that solution right away. I mean, you want short, but you don't want like too short. And this makes sense though in terms of like code quality. Like I know that okay, if we enumerate the shortest, and then we say okay, shortest, the keys is a length. To be more specific. If other in return shortest to I. Okay. So the shortest thing made sense. So thinking about, so imagine that, and that sounded kind of cool too. This video is way too long. I need to cut it off and go hang out with my friends. But yeah, that felt like a good catch. Like, oh, it's only the prefix of the shortest one. And nice, 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 nice. I like that one. It's too long. Yeah, if none of them match, it returns to I, which could be 0, which technically is wrong, right? I want to learn more about that zip solution. People using sums? Oh my god. time OK NK. Now, if we didn't do any store, we have to concatenate the string anyway. So we're gonna have to eventually return the slice. So to get O1, I don't know. But anyway. Now looking up for, I mean, the faster solutions are more complicated for sure. So this is like a brute force. I would say brute force, but it's a Java solution. I kind of hate that. So vertical scanning, what does that mean? Imagine a very short string and the common prefix end of the array. The above approach will still do S comparisons. One way to optimize this case is to do a vertical scanning. We compare characters from top to bottom in the same column. Same character index of the string before moving on to the next column. If strings equals null or string length is 0, return out. So that means we have a list of strings. If they're empty, so we're looping through, and we're saying that the character is so it's the first string character at 0. We're looping through, gets 1. So for each, so this is for each. This is the length of the first word. This is the length of all. This is all the words. If I equal to, so if we're maxed out, or if what's it called? J is not equal to, so if we're maxed out or they don't match, return the first word substring 0 to I. Okay. So do we do vertical scanning? Something like that. Return at 0. What? If we need a bigger one, then we turn the substring from 0 to I. Depending on how far we got. Okay, interesting. The divide and conquer for this is way too complicated. Like what? Like what? It's runtime OS ON login. Yeah, recursive for space is bad. Anyway, this is over. We're done. This is it. We're done. It's over. It's over.